This section is about graphing parabolas in a different format than we graphed them before. And then we're going to talk about both the distance formula and the midpoint formula. So a graph of an equation of the form y is equal to the quantity x minus k squared plus h is a parabola. And the form is called a vertex form because you can read the vertex right from the equation, and the vertex is h comma k. So let's look at the first one. We are going to first identify the vertex, and then we're going to graph parabolas just like we've been graphing before. So here's the deal on this one. Y is equal to x is just a plain x squared, so I'm going to say x minus 0 squared plus 2. So the vertex immediately is 0, comma 2. Perfect. Done. So we can graph it. The beautiful thing about this also is now we can set up that symmetry table quite easily. Perfect. So let's go for it. When I put 1 into this equation, 1 squared is 1 plus 2 is 3. So that means negative 1 will also be 3. If I put 2 in, 2 squared is 4 plus 2 is 6. And negative 2 will also be a regular 6. So let's graph them. Yeah, let's. So I need an x and a y here. Let's graph the vertex first, which is 0, comma 2. 1, comma 3 is the next point. Negative 1, comma 3. And then 2, comma 6. There he is. Negative 2, comma 6. And then is my usual graphing talent, drawing it. The axis of symmetry goes right along the y-axis. In fact, it is the y-axis. And we're done graphing. Isn't it awesome to have it in that form? It really makes things go faster. Now let's do this one. Yeah, let's. So, we identify the vertex first. It's 3, comma 1. So now we do our little symmetry chart. There it is. And now 3, comma 1 goes here. And we're going to put 4 in. So when we stick 4 in, we get the value 2 out. So when we stick 2 in, we'll also get the value 2 out. When we stick 5 in, 5 take away 3 is 2. Square 2 is 4. Plus 1 is 5. When we stick in 1, we will also get 5 because 1, let's stick in 1. Yeah. Negative 2 squared. So 5, yay! So the symmetry is really holding up nicely, isn't it? So now let's graph this. So we go 3, 1, 4, 2, 5, 5. Just taking my time, guys. And then 1, 5. And last but not least, 2, 2. And there it is. Ta-da! The axis of symmetry is actually the line x is equal to 3. Cool. Cuts it right in half. Done. Now this parabola is interesting because it doesn't seem to fit the form. Well, I'm going to take the form up just a little bit, a little notch, and say, yes, there can be a number in front here. And that number will actually determine whether the parabola opens up or down. In fact, since this number in front is negative, the parabola will open down. The other two examples, that number in front was the number 1, and both of those parabolas opened in an upward fashion because the 1 was positive. Having said that, it doesn't really impact getting the vertex, but so let's get the vertex. We still have the x minus h here squared and the k. Good? But you'll notice it's a little different here. It's not a minus, it's a plus, so we're going to take that opposite value as the coordinate, so -1. And you'll notice that on the end here should be a plus k, but it's really a -1, so we're going to take that negative with it. So the vertex here will be -1, comma, -1. Good? So we take the opposite sign here, but keep the sign here. So let's see if we can keep it all straight. So now, let's do our nice symmetry chart, because when we do our symmetry chart, it really just kind of makes us all relax. We put the vertex right here, and then we're going to go up and down. Perfect? Now, when we stick 0 in, let's stick 0 in over here, because now it's a little bit more complicated. It's not as easy to see. I'm going to stick 0 in for x. So I will get -2 times 1 squared minus 1. So it's -2. 1 squared is 1. When I multiply them, I'm going to get -2. Take away 1, which will be -3. So immediately I can fill that guy in, bada bing. Now when I stick 1 in, let's just do the 1 right here, just to make sure that I'm not making any errors. I'm going to put 1 in everywhere we see an x. So y is equal to -2, 2 squared minus 1. 2 squared is 4. 4 times -2 is a -8. Minus 1 will be a -9. We can write it here and, of course, here, and bada bing, we're totally done. So now we just need to graph. Let's graph in red. So there's x and y. So I'm going to graph the vertex -1, -1. There he is. I'll graph the point 0, comma, -3. There he is. Graph the point 1, comma, -9. Yay. And then we'll just graph the other ones, which are just symmetric. Nice. And then the graphs. The axis of symmetry here is the line x is equal to -1. It's always the x coordinate of the vertex. That's the axis of symmetry. We can see the y-intercept, although I didn't ask you. The y-intercept is the point 0, comma, -3. Fabulous. Notice how the parabola confirms it's opening down, and there are no x-intercepts in this particular parabola, right? Next. Before we get started with the distance formula, I need to do like a little correction on here. I need you to write a square here and a square here, okay, on the y's, and we'll use it. If we want to just find the distance between the 2 points, the distance formula is this. And I'll show you why. It actually results from the Pythagorean theorem. But let's do this first guy first, and then I'll graph him, and you can see why the distance formula will work. Okay, so first, what is this x2 minus x1 thingy-wingy? x1 is the x-coordinate of the first point. x2 is the x-coordinate of the second point. y1 is the y-coordinate of the first point, and y2 is the y coordinate of the second point. Now we will plug into the formula. So the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So please change that as you're writing in the lecture. So here we go, plugging in. x2 is 1, x1 is a negative 2, and then we're going to square that. y2 is 4, y1 is 0, then we'll square that. Let's go up here. 1 take away negative 2 will be 3 squared plus 4 take away 0 is 4 squared is 4 squared. So now we'll just do this. So that'll be 9 plus 16, 25. And the square root of 25 is 5. So it's 5 units between negative 2, 0 and 1, 4. So let's do the next one. Label x1, y1, x2, y2, and we're going to plug it in. Negative 5 minus negative 1 squared plus 6 minus 2. We love when they're all positive. It's great. So negative 5 add 1 is a negative 4, and we're going to square that sucker. 6 take away 2 is 4. We got to square that sucker. So the distance is equal to the square root of 16 plus 16. So it's the square root of 32. If we simplify this, we'll get 4 square root of 2 because 32 is 16 times 2. Good, and the 16 comes out as a 4. This is the exact distance, okay? If we want to approximate it, just do it on your calculator. It'll be approximately equal to 5.66 to 2 decimal places. Now let's go to the next slide. These are the 2 given points that we had on the previous slide, and I would like to graph them before I talk about the midpoint formula. So negative 2, comma 0 is right here, and 1, comma 4 is right here. So I would like to get the midpoint between these 2 points, but before I do, let me just draw that line segment here. We already discovered that the distance between this point, negative 2, comma 0, and this point, 1, comma 4, let me label my axes, you guys, will be 5. Let's take a look if that makes sense. If I think about it, I can have a nice right triangle here. The distance between this point that I'm just rolling on here and the point 1, 4 is 4, and the distance from this point right here that I just drew an arrow to and this point is 3. And you'll notice the Pythagorean theorem is involved because 3 squared plus 4 squared is equal to 5 squared. So if I think about it, the distance from here to here will be subtracting these y values, okay? And the distance from here to here will be subtracting the x values, okay? And then because it forms the right triangle, we know we can use the Pythagorean theorem to get the hypotenuse. Cool. Ta-da! For the distance. Now on to midpoint. Well, basically, the midpoint is going to be the average of the x values, comma, average of the y values, which is why it's looking like that. So if we do that, we're going to average the x values, so it's going to be negative 2 plus 1 divided by 2, and average the y values. Ta-da! We get this. So negative 2 plus 1 is negative 1 over 2. 4 divided by 2 is 2, so this is my midpoint. Perfect? Yay! So let's see how I did. Well, we have negative 1/2, 2. I kind of have to make it bigger because my graph isn't all that great, but you can see that that is pretty much halfway, and it is exactly halfway if everything was nice and accurately drawn between the 2 points, negative 2, 0, and 1, 4. Next, let's do the midpoint formula again, and we'll graph it. Negative 1, 2, label your axes. Negative 5, 6. There they are. And I could find the distance between them, and I can also find the midpoint. So let's use the formula. We're going to average the x's, add them up, and divide by 2. Average the y's, add them up, and divide by 2. So this will be negative 6 over 2, comma, 8 over 2. Negative 3, comma, 4. Negative 3, comma, 4. Ooh, I did a good job on that one. Negative 3, comma, 4 is the midpoint. That one's really nice. Now you'll be able to do the My Math Lab assignment associated with this lesson. Good luck, ask questions, and go for it.